Welcome to General Physics 1. In this video, we are going to continue our discussion on the application of Newton's laws of motion. So last time, we studied how the forces acts on a body in hanged on a pulley, or the forces acting on a pulley system. So in this video, we're going to look into the forces acting on an object sitting on an inclined plane. So let us first define what is an inclined plane. So an inclined plane is a simple machine that consists of a slanted surface along which objects are easier to push upward than to lift straight up. So suppose we have here, just look at this example. So this man is pushing a wheelbarrow up this container. So instead of lifting whatever is inside this wheelbarrow, instead of lifting it straight up, he make use of a ramp to transport this material. So examples of an inclined planes are ramp and stairs. So what inclined plane does is that it reduces the amount of force needed to transport an object from a lower ground to a higher ground by using a slanted surface. So just like how pulley systems reduces the amount of force required to lift an object vertically, so upwards of course, the inclined plane also has the same purpose, which is to reduce the amount of force required to lift or to transport an object from a lower ground to a higher ground, or vice versa. So let us now look into the forces that is acting or are acting on an object sitting on an inclined plane. So consider an object resting on a frictionless horizontal plane. So in these examples, in this video, we're still going to consider a frictionless surface. So let's consider this object sitting on an inclined plane. So if we slowly incline the plane, so of course the plane will be at an angle with respect to the horizontal line. So if we slowly incline the plane, and if there are no opposing forces such as the friction force, this object will start sliding. It will start accelerating down this plane. So objects sliding down an inclined plane or accelerating due to gravity, and the direction of the acceleration is parallel to the plane. So the force that causes this object to slide down the plane, so to slide down this ramp, is the force due to gravity. And as what the statement says, that the direction of the acceleration is parallel to the plane, because the force that causes of the body to accelerate is the force parallel to the plane. So the parallel component of the force due to gravity. So this will be the direction of the motion. So kung itong ramp naman nito naka-flip, so pa-slant sa kabila, so the direction of the motion of course papunta doon. And that is if there are no other forces, opposing forces acting on this body, and this is a frictionless surface. So therefore this body's tendency is to slide down the plane. Okay, so this body has a mass. So of course, since this has a mass, sorry, hindi ko na natanggal to. So the first force that we need to consider, of course, is that since this has a mass, the body would be acted upon by the force due to gravity. So the force due to gravity is always directed towards the center of the earth. So therefore, since this ramp would be sitting on the surface of the earth, for example, then the force would always be directed downwards, straight downwards. So the mass is sitting on an inclined plane, so it is in contact with this surface. So this surface will also exert a force towards this object. So the force, of course, that is directed towards this object, exerted by this plane to the object, is the normal force. So as you can see, this ramp is at an angle. So therefore, the force due to gravity is also at an angle with respect to the ramp. So if we draw here hiwalay na drawing, for example. Okay, so for example, ito yung ramp natin. And then this is the force due to gravity. So yung ramp natin, di ba, is at an angle. So of course, makikita natin that the force due to gravity is also at an angle with respect to the ramp. So here, we consider this ramp, the direction, so the line of action parallel to the ramp to be our x-axis, and the direction that is perpendicular to the ramp to be the y direction or y-axis. So since the force due to gravity is at an angle with respect to our parallel line, with respect to our x-axis or the x line of action, we need to resolve this force due to gravity into its parallel component, or in this case our x component, and our perpendicular component. So what we call these forces, we call this the perpendicular, because this force is perpendicular to the plane. So we have the perpendicular component of the force due to gravity. Yan. And then we also have, okay, so ipakita ko na lahat. So we also have our parallel component of the force due to gravity. So we label this, so since this parallel component is along the along the x-axis, so along the x-axis, we label this as the x component of the force due to gravity, or f of g of x, and then the perpendicular component to be f of g of y, or the y component of the force due to gravity. So recall the how we resolve vectors. So this is our vector. So suppose that kung i-tilt natin to, itong plane na to, suppose that this is a flat plane. So suppose that is a flat plane. So this would be our x and this would be our y. So this force due to gravity, if we tilt this back to a horizontal, itong plane, so the force due to gravity would be directed this way. So recall in your vector, sa lesson natin sa vector, when the vector is at an angle, we resolve it into its horizontal component. So we have horizontal and we have our vertical component. Yan. So yun. Okay, so since we assume this surface to be frictionless, so we assume this surface to be frictionless, we will not place here an opposing force. So unless you applied a force here, then we're going to draw another force vector here. But since we assume this to be frictionless and we did not include an external force, any applied force here, then the forces that is acting on this body that is sitting on a frictionless plane would be the normal force. We have the perpendicular component of the force due to gravity, the horizontal component of the force due to gravity. So since we already resolved this into f of g and f of y, so we can now ignore this one. So yan. So sabi natin kanina, 'di ba, sa previous slide natin, that objects sliding down on an inclined plane or accelerating due to gravity, and the direction of the acceleration is parallel to the plane. So therefore, asan na yun? Okay. So therefore, since the acceleration of the body is parallel to the plane, then the force that is causing the acceleration of the body is the force that is parallel to the plane, because as you can see, the force, the perpendicular force, or the f of g of y, is cancelled by the normal force. So therefore, f of n and f of g of y have the same magnitude, and they are canceling each other out. Dito, since we don't have an opposing force, so the parallel force of the force due to gravity, so parallel to the surface, is the force that causes our object to accelerate downwards or to slide down the plane. So how do we now solve for the magnitude of our of our perpendicular component and our parallel component? So what is the value of f of g of x and f of g of y? Because if this is just a downward force, we know that to solve for the force due to gravity, we just multiply the mass times the acceleration due to gravity. But since this is at an angle, we need to consider the angle. So how do we now look for the magnitude of our parallel component and our perpendicular component? So as you can see here, so if we move, of course, if we move this the parallel component down, so this would create a right triangle. So the angle here, class, so this would create an angle here between the force due to gravity and that is downward, and the perpendicular component. Meron tayo ditong angle, and this angle is equal to this angle. So yan, the same siya. So therefore, if this is 30 degrees, then this angle would also be 30 degrees. So if this is 40, that would also be 40 because they have the same magnitude, this angle and this angle. They have the same magnitude dito. So since this is parallel to the plane, so ito parallel siya dito sa plane, and this is perpendicular to the plane, we know that this angle is 90 degrees or a right angle. Kasi parallel to dito, and this is ay parallel tong f of g of x dito, and this is perpendicular. So kapag pinagdugtong mo sila, you know that you will create a 90 degree angle. So now we have a right triangle. So if we rotate this triangle, so yan, so we'll create a right triangle, and this is the angle, and this is the right, these are the angles, so right angle 90 degrees and the given angle. So the f of g would be our hypotenuse, f of g of x would be our opposite because our given angle is given in this side. So opposite to this angle is the f of g of x, and then adjacent to this angle is the f of g of y. So how do we now solve for the magnitude of the force parallel to the plane? So f of g of x is the force or the parallel component. So how do we now look for the value or the magnitude component? Okay. How do we now look for the value? So recall in the trigonometry that yan. So since we have here right triangle, we can use the trigonometric function. So for right triangles. So sine, sabi dito, sine is equal to opposite divided by hypotenuse. So ayan. So alin dito ang opposite? Alin dito ang hypotenuse? So sabi natin that opposite to the given angle, okay, so opposite to the given angle is itong side na to. So the parallel component, which is f of g of x. And then our hypotenuse here is the force due to gravity. So ayan. So therefore, we can substitute opposite over hypotenuse with f of g of x divided by f of g, or the force due to gravity and the parallel component. So we can now equate these two so that we have sine theta is equal to f of g of x divided by f of g. So if we rearrange this, because what we want to look for is the value for the parallel component. So to look for the parallel component, cross multiply. So if we multiply this, we will get f of g sine theta is equal to f of g of x. And rearranging this, we'll have the solution for our parallel component. So the value, this equation would help us solve for the force causing the acceleration of the object. So f of g of x is equal to f of g sine theta. So this one class, this f of g, you can substitute here m of g because we know that mass times the acceleration due to gravity would give us the force due to gravity. So you can, if the given in the problem is mass, then you can use mg. So use this in place of this one. But if the given is the force due to gravity, then you can just substitute this with the given value. Pero kung mass, you need to solve for the force due to gravity. Okay, so this equation now will be used to solve for the force causing the object to slide down, to accelerate down the inclined plane. How about the magnitude for the perpendicular component? So the perpendicular component, this would help us determine the normal force. So later, kapag na-discuss na natin yung friction, so this is how we're going to solve for the normal force in case of situation na nagbibigay ng inclined plane, including inclined planes. So this is the perpendicular component. Yeah. Okay, so dito, to look for the magnitude of y, we're going to use cosine theta is equal to adjacent over hypotenuse, because yung ating yung perpendicular component natin is the side adjacent to the given angle. So therefore, in the trigonometric functions, the one that has adjacent in the equation is the tangent and the cosine theta. So since we want to look for the value of this f of g of y, and this is the adjacent side, we're going to use this cosine theta. So cosine theta is equal to adjacent divided by the hypotenuse. So here, the adjacent, sabi na nga natin, is the perpendicular component, which is the f of g of y, and our hypotenuse is the force due to gravity. So we can substitute adjacent with the perpendicular component and hypotenuse with the force due to gravity. So that we can equate cosine theta is equal to f of g of y divided by the f of g. And since we were looking for the value of f of g of y, then we cross multiply so that we'll get f of g cosine theta is equal to f of g of y. So rearranging this, so this is now the equation that will help us solve for the value of the perpendicular component of the force due to gravity. So this perpendicular component, so this perpendicular component of the force due to gravity would help us solve for the normal force, because normal force and this perpendicular component are opposite to each other and they are canceling each other. So they must be equal since that is the case, di ba? Hindi naman lumilipad yung object doon sa ramp. So therefore, since the object is in contact with the ramp, then the force must be equal. So this now can be used to solve for our normal force. So that is why in other resources, dito, ang nakalagay dito is normal force is equal to Fg cosine theta. So you can consider this as the equation for the normal force. Kasi di ba dun sa ramp natin, if this is the ramp and this is our f of g of y, so perpendicular to the ramp. So ito yung ramp, andito yung object, and the normal force is directed papunta doon. So this is Fn. So these two must be canceling each other out because this one is not flying. So hindi naman siya lumilipad. So wala namang net force along this line of action. Okay. So how about looking for the acceleration of the object? So di ba sabi natin the object is accelerating downwards due to the force, due to the parallel component of the force due to gravity, or the f of g of x. So therefore, we'll use this equation, f of g of x equals f of g sine theta, in order to solve for the acceleration. So from Newton's second law, we know that net force is equal to mass times acceleration. And we also know that the force due to gravity, or the weight, is equal to mg. So mass times the acceleration due to gravity. So we can substitute this equation to here. So dito sa f of g of x, so since we're looking for the acceleration along the perpendicular path, so we are going to include here that this is the acceleration along the x-axis. So yan. So mass times the acceleration on the x-axis is equal to mass times the acceleration due to gravity divided times sine theta. So ayan, so napalit na natin, na-equate na natin. So just by substituting. So yan, and ito dito. So what we want to look for is the acceleration of the object. So to look for the acceleration of the object along the plane, so down the plane, so we need to isolate acceleration. So therefore, so erase ko lang tong mga nakasulat. So therefore, we divide both sides by, yan, so tatanggalin natin tong mass, lipat natin siya dito. So divide both sides by mass, so cancel this one and maka-cancel dito. So as you can see, the acceleration of the object in an inclined plane do not depend sa mass ng object, but depends only on the angle of the incline and the acceleration due to gravity. So to solve for the acceleration of an object in an inclined plane, we multiply 9.8 meter per second squared with yan, sine and the given angle. So this angle is this one, or just as the same as the angle in this part. So that would be the solution for the acceleration of the object. So let us now have an example. So a 40 kilogram block slides down on a 30-degree incline. So letter A, find the force causing the block to accelerate down the plane. B, find the acceleration. Letter C, find the force exerted by the plane to the block. And letter D, find the pulling force needed to prevent the block from sliding. So step number 1. Okay, so step number 1, so draw a free body diagram or illustrate the situation. So free body diagram. So here we have a mass, so an object with 40 kilogram mass. So this object, again, of course, this will be acted upon, since it has a mass, acted upon by the force due to gravity. Ayan, so force due to gravity. And since this object is sitting on this plane, it is in contact with the surface. So this surface will exert a normal force. So will exert a normal force papunta dun sa taas. So perpendicular. Suppose that is a perpendicular. So yan. This is normal force. Okay, so this is at an angle of 30 degrees. So therefore, we need to resolve the force due to gravity to its perpendicular component. Okay, so perpendicular component and its so its parallel component f of g of x and its perpendicular component, which is f of g of y. So yan. So we need to resolve. So that would be the force that is acting on our body. So dito, wala pa tayong So sabi dito, this is, let's assume that this is a frictionless surface. So therefore, wala tayong opposing force. So step 2, let us now create, step 2 is to create or construct equation. So, yan na. So, puntahan na natin yung problem natin. So, letter A, ang kailangan natin is to construct an equation to solve for the force that is causing the block to accelerate. So, sabi natin that the force causing the block to accelerate down an inclined plane is the force, the parallel component of the force due to gravity. So, this one. So, we need to look for the equation for this one. So, summation of forces along the x-axis or the net force, since wala naman tayong iba dito, so wala tayong opposing force, so we'll only have that the net force is equal to the parallel force of the force due to gravity. Ayan, so that will be, and we know that f of g of x is equal to fg sine theta. Or if we replace this, since wala naman given na force, we can replace this with mass times the force due to gravity. So therefore, summation of f of x or net force is equal to, papalitan natin to with mass times gravity, acceleration due to gravity, sine theta. So, ano yung mass ng object? So, let us now substitute. So, evaluate natin tong equation na to. So, ano yung mass ng object natin? So, the mass of the object is 40 kilograms. So, ayan, given yung mass, which is 40 kilogram. And then, yung acceleration due to gravity is 9.8 meter per second squared. Sine, yung given angle natin is 30 degrees. So, to solve for this, 40 times 9.8, that would be 392 Newton sine 30 degrees. So, 300, dito ko na isulat sa kabila. So, pupunta doon. Okay, so, 392 Newton sine 30 degrees is equal to 196. So, 196, ang tawag dito? Newton. So, this is the force that is causing our object to slide down the plane. So, this is this one. So, the force that is causing our object to slide down this inclined plane. So, this would be our final answer. So, sabihin nyo na lang that the force causing the object to accelerate down the inclined plane is 196 Newton. So, that would be the answer to our letter A. So, question number A from our problem. So, letter B. Sabi dito, find the acceleration of the object. Okay, so again, find the acceleration. So, hindi ko na i-drawing yung ibang force. So, yung acceleration of the object natin, di ba, is parallel to the inclined plane. So, this is the direction in this, since this is moving this way, inclined this way. So, this must be sliding towards this direction. So, what causes our object to accelerate is our force, the parallel force due to gravity. Ayan. So, the parallel force due to gravity. And that is f of g of x. And, sabi natin, to solve for the acceleration, we can use Newton's laws of motion, wherein second law, F net is equal to ma. So, therefore, kanina, alam natin that the summation of forces along the parallel line, along the x, is equal to f of g of x. So, substitute natin siya with the mass g times, walang x nito. Mass times the acceleration due to gravity sine theta, and this one is mass times the acceleration, and this would be acceleration along the x-axis. Divide both sides by mass. So, yan. Divide both sides by mass. And acceleration is equal to g sine theta. Okay, so ang angle natin dito from the problem is 30 degrees. So therefore, ang acceleration natin, if we substitute this with our value, so the acceleration due to gravity is 9.8 meter per second squared, and the angle is 30 degrees. So 9.8 meters sine 30 degrees, 9.8 meter per second squared sine 30 degrees will give us an acceleration equal to 4.9 meter per second squared. So that would be the acceleration of our object. So, yan. So at a 30-degree angle, the object will accelerate at a rate of 4.9 meter per second squared. So yan ang ating acceleration when this angle is when this ramp is raised at a 30-degree angle. So letter C. So ano yung letter C natin? Find the force. Ano yung problem natin, letter C? Balikan natin yung letter C. So find the force exerted by the plane to the block. Okay, so find the force exerted by the plane to the block. Okay, so the force exerted by the plane to the block. So ano ba ang force na yon? So sabi natin that of course that force would be the normal force. So this is the force exerted by the plane to the block. And sabi natin kanina, diba, that the force exerted or the normal force is oppositely directed with the perpendicular component of the force due to gravity. And we know that the perpendicular component of the force due to gravity is equal to, so Fg of y is equal to force due to gravity cosine theta. So now, since we know that this is not moving along this line, so this is not moving towards this direction, this is also not moving towards this direction, so we know that the summation of forces along this line is equal to 0. So how do we solve for the net force along the y-axis? So to solve for the net force along the y-axis, so we suppose that this one is positive, this one is negative. So to get for the value, we need to get the sum of these two. So F of n, or normal force, plus negative F force due to gravity is equal to, ayan, so F of n. So since this is negative, so let's just use negative Fg of y. F of g of y is equal to summation of forces. So this one, we can equate now this one, palitan natin ito. So that magkaroon tayo ng F of n, normal force, minus the perpendicular component is equal to 0. And then, so to solve for the value of the normal force, so F of n is equal, transpose natin tong perpendicular component of force due to gravity sa kabila. So, ayan. So, F of n is equal to F of g of y, or is equal to Fg cosine theta. So, let us now solve for the value over F of n. Sorry. So, ayan. F of n. And this is our Fg of y. So, F of n, sabi natin, F of n is equal to our Fg of y is equal to force due to gravity cosine theta. So, F of n is equal to, so F of g is also equal to mass times the gravitational acceleration. So, therefore, mg cosine theta. So, palitan natin. So, we know that this mass is 40 kilograms. So, 40 kilograms times 9.8 meter per second squared times cosine So, times cosine 30 degrees. Kasi yung angle dito is 30 degrees. So, cosine 30 degrees. So, 40 times 9.8 is 392 Newton. Cosine 30 degrees. 390 newtons cosine 30 degrees is equal to 339.48 Newton. Or, kung following this so 339 or approximately 339 Newton. So, this would be our final answer. So, the normal force or the force exerted by the ramp, by this surface to our object is 339 Newton. Okay. So, how about if we want to prevent our object to slide down the plane? So, what is the amount of force needed what is the amount of the pulling force we need to exert to prevent this object from sliding? So, let us now create an equation. So, ito muna. So, sabi natin that the force causing an object to slide down the plane is the parallel force of gravity. F of g of x. So, what about we want to prevent this? So, ano yung force na kailangan natin i-exert? So, we would be pulling this one. So, suppose naglagay tayo ng string. Sabihin natin na yan yung tension force from the string. So, ano yung kailangang value nitong force na to in order to prevent this object from sliding? So, since we know that we want to prevent this from sliding, then the summation of forces along this axis, the x-axis, must be equal to 0. So, how do we look for the value or the solution for the summation of forces? So, we have here, suppose that this is our negative direction, or whatever direction you want. So if this is your positive or negative, and suppose that this is our negative direction and this is our positive direction. So, pataas, negative, pababa. Pataas, positive, pababa, negative. So just suppose. So we want to look for the summation of forces along this axis. So to do that, we need to get the sum of the tension force from the string and the force due to gravity, or the parallel force due to gravity. So, since this is negative, this is just equal as saying tension force minus F of g of x is equal to the summation of F along the x-axis. So, we can substitute this with this expression so that we have F of t minus F of g of x is equal to 0. And then, to look for the value of the required force, so the pulling force. So, yan. Ilipat lang natin to the other side. Magiging positive g of x. So, yan yung ating solution for our pulling force. So, yan yung force required to prevent this from sliding. So, f of g of x is equal to to fg sine theta, and fg is equal to mg. So therefore ft is equal to mg sine theta. So let us now solve for the value of the force. So letter D ito, di ba? So again, i-drawing ko lang ulit. So this is the parallel component of the force due to gravity and our force preventing our object to slide. Sabihin na natin na meron siyang string dyan, so that we call this tension force. So, tension force, so from our derivation, tension force is equal to mg sine theta. The mass of this object, again, is 40 kilogram. And ang angle natin, given angle is 30 degrees. So, ang mass natin is 40 kilogram times acceleration due to gravity is 9.8 meter per second squared sine 30 degrees. 392 newtons sine 30 degrees. So the tension, the force needed to prevent the block from sliding is equal to 196 Newton. So you need to exert here 196 Newton in order to prevent this from sliding. So yung tension force, since parehas siya sa value ng parallel force, they would cancel each other out. So therefore, yun na yung force preventing this box or this object from sliding down the plane. So ang final answer natin ngayon para sa ating problem, so letter A natin, di ba? Fg, the force that will cause an object to accelerate, is equal to 196 Newton. So letter B, the acceleration of the object. So the acceleration of the object is 4.9 meter per second squared. And then letter C, the force exerted by the surface to the object, or the normal force, is equal to 339 newtons. And then the force needed to prevent this box or this object from sliding is 100. So sabihin natin na tension force or yung pulling force needed to is equal to 196 newtons. So sa final answer nyo, make it a sentence form para parang concluding statement. So make it as a sentence form para concluding statement yung kalalabasan ng final answer ninyo. So that would be for our example for the inclined plane. So in our next example, in our next video, we're going to show an example of a combination of a pulley problem and an inclined plane. So a combination of inclined and pulley, so that you would be introduced to a more complex way of solving force problems. So that would be all, and see you in our next video.